Now I'm going to program a simple part. This is so you can see how I lay out a program as I code it, and I'll go over each line separately so you can see exactly what's going on and the M codes and G codes that I use. The first thing we need to do is decide where we're going to put our datum, so we can set the work shift in the program. Since all the dimensions seem to be coming from the bottom left hand corner, this seems like a good place to place it. The first line is our tool call line. It's where we tell the machine what tool and what offset we're going to be using. So I'll start off with the search number N1, then followed by T0101. That defines tool 1 and offset 1. The 15mm end mill in brackets is an operator's note, so the operator knows which tool we're running. This is not read by the machine. M06 is our automated tool change M code. This tells the machine to take the cutter from the right position in the carousel and place it in the spindle. Here is our G10 line. You should be slightly familiar with this by now. Our G10 tells the machine that we wish to set the datum position. This is used if the billet of material is always loaded in the same position each time into the machine, if we have a standard vise that's fitted, or a fixture that's always loaded in exactly the same position. L2 tells the machine we're going to set the datum. P1 is the code we use to put the following information into the G54 offset. This is called upon every time we call up G54 within the program. Our G54 position will be our datum position. All the dimensions from this component will be measured from our datum position, so our datum is X0, Y0. I'm taking the top face of the component as Z0. The dimensions on X, Y and Z on this line tell the machine the distance from the machine datum to our work shift datum. Here is our safety block. I place this after every tool change in case anything changes, so we can start the program from any tool without having to reread the beginning header of the program. So G90 tells the machine we're using the absolute coordinate system. G54 tells the machine which datum we are using. G21 tells the machine we are using the metric measuring system, and G17 defines our plane that we are cutting on. To set the revs per minute of our tool, we use S2000. This sets it to 2000 RPM. M03 turns on the cutter to rotate in a clockwise direction. If we filled out the tool table correctly inside the machine controls, G41 will add the correct amount of offset to our tool for cutter compensation. We would have added a tool radius of 7.5mm in the tool table to make a 15mm cutter cut at the right size. So G42 turns on our cutter compensation to offset the cutter to the left of the component. Now everything is set up, we can move our cutter to the start position that we wish to cut. We do this by using the G00 rapid travel move, and we take it to X0, Y0, which will move us to our datum that we set with our G54 and our G10 offsets earlier. I like to move the cutter down in Z on a separate line when we're under a G00 rapid command. This is so I can visually make sure that the cutter is moving safely inside the machine and missing any clamps or vices that may be on the table. So the final movement while in rapid is bringing the Z down, and the M08 turns on the coolant. Now it's time to start cutting. Our G01 command plunges our cutter into the material by 10mm, designated by the Z-10 dimension. For the sake of the tutorial, I'm using a feed rate of 50mm per minute, defined by the F value. This can change greatly depending on your material, size of cutter, type of cutter, rigidity of the machine, size of the machine, etc. With the G01 linear feed rate command still active from the line above, I now move the cutter 40mm up into our first corner of our taper, with a feed rate of 100mm per minute. Now, because draftsmen are really lazy people, they didn't add the dimension for the end of the taper for us, so we need to work it out by using some simple geometry maths. Let's look at how we do that. The length we need to calculate I've added with a question mark. We know our angle is 30 degrees, and we know the opposite length is 80mm minus 40mm, which is 40mm. So we need to draw a right angle triangle that looks like this. To work out the bottom length of the triangle, we need to do a little bit of trigonometry. For that, we need to know which trigonometry equation to use. Luckily for us, I've included this table as a handout underneath this lesson. So, which equation do we need to use? Well, we know angle A, and we know the length small a, and we need to find out the length of small b. So the best equation for us to use is b equals small a cotan angle A. So let's start with that equation on our triangle. We can change that equation around by using linear transposition. For more information on how to do this, keep an eye open for my course Machine Shop Maths. So we start our equation with question mark equals length A divided by the tangent of angle A, which translates to 40 millimeters divided by the tangent of 30 degrees. So, using the scientific calculator and punching in tan 30, we can conclude that it equals 0.5773. With reference to our trigonometric equation, we now take our 40 millimeters and divide it by 0.5773. And that equals 69.282. And this is the length we are looking for our triangle. Now we can add that to our drawing and finish off writing our program. So, now we know our x dimension, we can enter it into the program, followed by y80. This is the y dimension from the datum to the top of our profile. Now we move our cutter to the beginning of our radius using x120. Now we can machine our radius using the GO2 command. The GO2 command is our clockwise radial movement. The x and y positions is the endpoint of our radius, and r defines the size of our radius. In this case is 20 millimeters. I'll slow the feed rate down to 50 millimeters per minute to reduce chatter as we're cutting this arc. We now tell the machine that we wish to cut in a straight line. For this, we use our GO1 linear move command. Our y dimension is the endpoint of where we wish to move to, in this case right down on the bottom of the material where the datum lies, and I've increased the feed rate back to 100 millimeters per minute. Here I've taken our cutter 20 millimeters past the start point to give us a nice clean edge. Now all we need to do is bring our cutter away from the component. For that, I use G00, the rapid travel command. I'll bring the Z up 10 millimeters above the face of the component, and I'll turn the coolant off with MO9. I now tell the cutter to go back to our machine datum position, which is also our tool chain's position. The G53 sets our datum back to the machine datum away from our work shift datum that we defined with G54. Now we can give the dimensions x0, y0 and z0, and the machine takes them from our G53 datum. MO5 tells the cutter to stop rotating. G40 cancels our cutter compensation, and MO1 is our optional stop. So if the operator wishes to stop the machine at this point and measure the component, he simply has to push the optional stop button on the controls. And that is how I write a basic milling program. We will use this information later in the course when I start adding different cycles and more advanced techniques.